Hey, hi, Rajan this side. Welcome to the channel. So today we discuss all four problem asked in today's LeetCode Biweekly Contest 170. Let's look at the first problem. It says you are given a positive integer n and let s be the binary representation of n without any leading zero, right? And a reverse of a binary string is obtained by writing the characters of s in a opposite order, right? Okay. Now you may flip any of the bits. So flipping means changing the character 0 to 1 or changing the character 1 to 0, and each flip affects exactly one bit, right? And we have to find out the minimum number of flips requires to make s exactly equals to the reverse of its in original form. For example, let's say 10. For 10, the binary representation is 1010, right? So this is the binary representation. The reverse of it is 0101, right? And if you see, to convert this string to this string, you would be having 4 number of flips. See, all the characters at each position is different, right? So we have to convert 1 to 0. So to flip first character, then second character also, third also, fourth also, right? So because all the beats are different in original and its reverse form, so minimum 4 number of flips is required. So yeah, it's an easy problem. Let's see how we can approach it. To solve first problem, what we can do, we can first convert the given integer n into its binary representation. Let's say the binary representation looks like something 101001 or 0, something like this, right? And as per the problem statement, we have to find out the number of flips required so that we can convert s to its reverse of it, right? So fdef, let's say fdef is the reverse in the binary representation, so it would be reverse of it exactly. So 0 1 0 0 101, right? So if you see, to convert s to s dash, how many flips are required? Again, see, so we can go through each of the index and we can check whether the bits are same or different. If they are different, means that we have to apply a flip operation. So here you need 1 2 3. Here you don't need to apply any flip operation because both are exactly the same, right? So don't need to apply flip operation. Again, need. So total 6 number of flips required to convert s to s dash, right? So there are many ways to solve it. First, so one way is to find out both s and s dash and go through each of the index. So you can use a for loop. For int I equals to 0, I less than n minus 1, I plus plus. Just check if both are different or same. If both are different, then flips plus plus, right? Just increment the flips variable. Now another way could be the one which I have used in a problem statement. Like, to solve this problem, what I have done, I have first find out either s or s dash, because both are like exactly reverse of each other. So first find out any of the string, right? So let's say this is my string 01000101. What I have done, I have just checked first and the last. Check first and last. If both are same, then no need to apply any flip operation. Otherwise you would need 2 number of flips plus equals to 2, because first to convert 0 to 1 and then 1 to 0, right? So if both are different, what it means that in s dash, in the reverse of it, for the reverse of it would look like, here it would be 0 and here it would be, sorry, here it will be 1, here it will be 0, right? So you will have to convert 0 to 1 and then 1 to 0. So total 2 number of flips, right? That's why I have checked first and the last first. If both are different, plus equals to 2, because you need 2 number of flips, right? Again check second and second last. If both are different, again plus equals to 2, and if both are same, then no need to apply any operation. And that's it, and that's all about the explanation. I hope you understand it. If you find any difficulty, please write a comment. I'll resolve it, right? Yeah. So let's look at the code now. Here is the code of first problem. So this is your given integer and first find out its binary representation. So once you get the binary representation, so actually this is a reverse of a binary representation, right? So but it doesn't matter in this problem statement because both are exactly reverse of each other, right? Now find out the length of this representation, this binary bits. So start from checking first and the last, then second and second last, and so on, right? So start with l is equal to 0, r is equal to length minus 1, right? n minus 1. So this is the number of flips required. Now while l is less than r, just check if left bit and the right bit are same or not. If they are different, then flip plus equals to 2, because we have to convert both the bits, right? We have to flip both the bits, so that's why flips plus equals to 2, and then L plus plus R minus minus, right? So yeah, that's all about the first problem. Let's look at the second problem now. In second problem, you are given two integers num1 and num2, right? That represent for inclusive range from num1 to num2, right? So both are inclusive. Now the waviness of a number is defined as the total number of peaks and valley. Let's see what is peaks and valley. So a digit is a peak if it is strictly greater than both of its immediate neighbors, right? So it should be strictly greater than its previous digit, as well as it should be strictly greater than its next digit. And for valley, it should be strictly less than its previous digit, as well as it should be strictly less than its next digit, right? Now the first and the last digit cannot be peaks and valley, because see, for the first number there is no previous digit, right? So there is no previous digit, since it won't be a peak. And and same applies for the last digit, because there is no next digit. Now any number of and any number with fewer than 3 digits has waviness of 0, right? And that makes sense also, because if you have less than 3 digits, then there won't be any previous or the next digit, right? That's why it should be having at least 3, so that we can compare with both previous and next digit, right? And we have to find out the total number of waviness of all the numbers from nums1 to nums2, right? Num1 to num2. It's a brute force problem. So what we can do, we can easily iterate from num1 to num2, and for each digit we can first find out its how many peaks and valley are there. And to find out peak and valley, we can easily again like go through all the digits, and we can compare current digit with previous and next. If it is more than both, then it's a peak, and if it is strictly less than previous and next, then it's a valley. So let's directly look at the code. So this is your num1 and num2, right? So iterate from num1 to num2, right? So let's say this is my current number. First find out its decimal representation. So I have used a string, right? So to convert this num into the string form. Now reverse it, because this is from LSB to MSB, right? So this will be from LSB to MSB. So let's take one example. Let's say your current num is 1 2 3, right? So after applying this operation, because since it iterates from LSB to MSB, your str would be 3 to 1, right? Because it iterates from right to left. So just reverse it. So after reversing, again it would be 1 2 3, which is same as the original num. Now once you know the digit, like, so once you know the number, once you know all the digits, we can easily find out its length. Here the length is 3, right? Then iterate from second digit to second last digit, because we know that first and the last number cannot be peaks and valley, right? So start from index 1 to n minus 2, right? So from second to second last. Just check if it is like if the current digit is peak or valley. So for peak, your current digit should be more than both previous and the next digit, right? So your str of I should be strictly greater than str of I minus 1, and str of I is strictly more than str of I plus 1, right? So for peak, this is the condition, and for valley, exactly reverse of it. Just it should be less than previous and next, right? So just check if it is either peak or valley. If either of them is true, then just update your answer plus plus, right? And at then return your answer. So that's all about the second problem. Let's look at the third problem now. In problem number 3, you are given an integer n and an integer target, and we have to find out the lexicographically smallest array of integer of size n, such that the sum of all of its element is exactly equals to target. And if you take the absolute value of all the elements, it should be a permutation of size n, right? And if no such array exists, just return an empty array. We know what is permutation. A permutation of size n is nothing but a unique numbers from integer 1 to n, right? That consist of all the numbers from 1 to n. So let's take one example. Let's say you are given n is equals to 3 and target equals to 0, right? So we have to find out an array of size 3 such that First condition is sum of all the elements should be equals to target, means sum of all the elements should be 0, and if you take the absolute value, it should be a permutation of size and 3. So if you take the absolute value, so the number you would be getting is 3, 1 and 2, which is a permutation of size 3, right? 3, 1 and 2. So here in this case, the lexicographically smallest is minus 3, 1 and 2, right? So there are many of them. See, all of them are uh, like a valid answer, but since we have to find out the smallest one, so this is the smallest lexicographically smallest array, right? So yeah, it's a good problem. Let's see how we can approach it. In problem number 3, we have to find out the lexicographically smallest array of integer of size n such that the sum of its element is equals to target and the absolute value of its element is a permutation of size n, right? We know what is permutation of size n. This is nothing but all the numbers from 1 to n, right? So 1, 2, 3, 4, 5 up to n. Like you can rearrange it in any order. So this is how the permutation of n numbers look like, right? And we know that we have to find out an array whose sum is target, but absolute value should look like this, not the original array. And if you notice it carefully, if after see, if you do absolute value, it would just change its sign, right? If it is negative, it would make it positive, and if it is positive, it won't like so it will anyway be positive, so it will just change the sign, right? Nothing else, it won't change the number. So your final answer would look like, it would still be in permutation, but few of the integers would be negative, right? Few of the integers would be negative. Let's say p is nothing but a set of positive numbers, so we know that your answer would be still be a permutation, but few of the digits would be positive and few of the digits would be negative. So in the first test case, I hope you remember, we have to find out the n was 3 and target was 0, right? And your answer was minus 3, 2, 1. See, there are two numbers which are positive and one number which is negative, right? 3 was negative and 2 and 1 were positive. So let's say p is the set of positive integers and n is the set of negative numbers. So here, so in this example, your p is nothing but 1 comma 2, because this is the positive integers, and n is the set of negative number, which is 3, right? So let's say p and n. Now since the total sum must be equals to target, what it means, your sum of p, right, the sum of all the numbers minus sum of all the numbers in this set negative is equals to target, right? This is what you are looking for. See here, the sum of p is 1 to 1 plus 2, 3, and the sum of n is 3. So 3 minus 3 is target 0, and target was 0, right? So this is the relation. Now let's try to find out this sum of p. So can we write this way? The sum of all positive integers is nothing but the sum of all the numbers from 1 to n, which is n into n plus 1 divided by 2 minus sum of negative numbers. We can find out, right? It's easy. If you want to find out all the positive numbers, so from all the numbers just remove the negative number, you would get the positive number, right? That's what I have done here. Sum of p is nothing but n plus 1 divided by 2, the sum of all the numbers minus, if you remove the negative numbers, what you left with positive number, right? So sum of p can be written as this way. Now if I just try to use this formula, minus, so this sum of all the positive numbers is this, minus sum of negative numbers is equals to target, right? So can I write this way? Let's say this is sum, let's say I'll call it sum minus sum of all the negative numbers 2 into is equals to target, right? Target. Can I just rearrange it? Your sum of all the negative numbers would be sum minus target divided by 2, right? This is what sum of all the negative numbers. sum minus target divided by 2. Even in this example we can so quickly check what is your sum in this example. 3 plus 2 plus 1, right? N plus 1 divided by 3 into 3 plus 1 divided by 2, which is nothing but 6. 6 minus target 0 divided by 2, which is 3. See, sum of negative numbers is 3 here. So yeah, I hope you understand what I'm doing here. Now we know the sum of all negative numbers is sum minus target divided by 2. So from this relation we can say that the solution would exist only if your sum minus target is greater than or equals to 0, and this sum minus target is a multiple of 2, is even. So these are the two conditions, because we know that the sum of negative numbers is a positive number, right? Because I have just added without the negative sign. So to make this number integer, first your sum minus target should be greater than or equals to 0, and this number should be even number, right? Then only your solution exists. If both condition holds true, then we can find out the solution. So we can find out the solution using a greedy method, right? So to apply the greedy method, we first find out what is the sum of all negative numbers. Let's say that number is x, and that x is nothing but sum minus target divided by 2, and this sum is nothing but the sum of all the numbers from 1 to n, which is n plus 1 divided by 2. If you know the x value, and so what this x means, x is nothing but the sum of all negative numbers, right, which you have chosen as a negative number. So here, isn't it optimal to choose as maximum as possible? So here if you see, minus 3, 2, 1 was your answer, right? But there was one more possibility, 3 minus 2 and minus 1, right? Here also sum is 0, sum is equals to target, and if you take the absolute value, this is also a permutation. But we have not chosen this one because we want the lexicographically smallest one. Now to find out lexicographically smallest, try to find out the maximum number which can be converted to a negative number. So here what we will do, we will start from n int I equals to n, right? Start from max, I is greater than or equals to n, and I minus minus, right? Just check if your current number I, if your current number is greater than or equals to x, what it means? It means that we can convert this integer to a negative number, right? And this is the max possible because we are starting from n to 1. If this is greater than or equals to x, just convert this integer to a negative number. So just convert I to minus I, and that's it. So that's it. The problem is solved. Here if you see, your target was 3, right? You have to find out the numbers that can be converted such that the sum of negative number was 3. If we start from 3 itself, the first number itself can be converted, right? That's why we have converted 3 to minus 3. That's what I have done here. To apply the greedy method, start from maximum till minimum and try to find out those integers that can be converted to this integer, right? That can be converted such that the sum of negative number is x, right? So here just start from n, I equals to n, I greater than or equals to 1, I minus minus. If your current number is greater than or equals to x, just convert I to negative I and just subtract x minus equals to I, right? X minus equals to I, just subtract it from x, right? So this way you would convert all the required integers such that the sum of negative numbers is x, right? And so yeah, that's it about the explanation. If you have any difficulty anywhere, just write a comment, I'll resolve it, right? So yeah, let's look at the code now. Here is the code of third problem. So you are given n and target. First find out the sum of all the numbers from 1 to n, right? n plus 1 divided by 2. Then find out diff. Diff is nothing but sum minus target, right? So in the explanation part I have mentioned that. So this is the diff, sum minus target. Sum minus target is the diff. Now as mentioned before, to your answer would exist only if your this diff is positive and this diff should be a even number, right? Because this has to be divided by 2, that's why it has to be an even number. So that's exactly what I have checked here. If your diff is either negative or if it is not an even number, just return an empty string, otherwise your answer would exist. So this is my answer and this is my diff divided by 2. X is the diff, x is nothing but diff divided by 2, right? So x is the sum of all negative numbers, which is nothing but diff divided by 2, right? So once you know x value, So one more condition you should check: your sum of all negative numbers shouldn't be more than n plus 1 divided by 2, right? That's what I have checked. If your x is greater than sum, just return an empty string. Otherwise, the problem is pretty easy. Just apply a greedy algorithm. Start from n, start till 1. So I is equals to n, I like greater than or equals to 1, I minus minus. If your current integer, if your current x, like the required integer, is more than this integer, right? So we can easily choose this I as a negative of I, right? So just subtract it from I and just keep push minus I to the answer, right? Because we can easily convert this I to a negative integer, right? So that's why I have pushed minus I. Otherwise, push plus I. So minus I or plus I. And after then, since we have to find out the smallest lexicographically, just sort it. So if you sort it, your minimum number should be present at the first and max number should be present at the end, and at the end return your answer. So yeah, that's it about the third problem. Now let's look at the fourth problem. This problem number 4 is exactly same as the second problem. The difficulty only comes in the constraint part. So in second problem, the num1 and num2 can only go up to 10 to the power 5, right? But here it can go from 1 to 10 to the power 15, right? So the max value is 10 to the power 15. So the brute force solution won't work, right? So yeah, I have almost made the video solution for it. Just wait for 10 or 15 minutes. I'll be posting the solution of fourth in a separate video. I have almost made the video solution, right? So yeah, that's all about like today's contest. If you find the video helpful, please like, share and subscribe to my channel, right? Yeah, thanks for watching.